Hello, everyone, and welcome to today's webinar, Hyper-Realistic Design Workflows for Additive Manufacturing. My name is Lisa Hannon, and I'll be your moderator. I work on the marketing team here at Fisher Unitech, and I'm excited to be hosting this session today with Danny Levy. I'm pleased to introduce today's speaker, Danny. Danny is one of our application engineers at Fisher Unitech and has presented on many webinars and is very knowledgeable about the subject. And today he's going to share design workflows for additive manufacturing. We will be answering questions at the end of the session. If we don't get to your question today during the webinar, we will be sure to follow up with you afterwards. If you have a question for our speaker, please make sure you put it through the Ask a Question or Chat section of the webinar. Thank you for joining, and now I'd like to hand the microphone over to Danny.
Cool. Thank you, Lisa. Yeah, pretty excited to share this content. I've kind of been doing a sprint for getting some live examples together for you. Again, my name is Danny Levy. I've been working in additive manufacturing for about 6 years now. I'm based out of Chicago, and I run a lab out of our Chicago office with a bunch of different pieces of equipment. So I really kind of wanted to put my knowledge to work in this webinar. It is going to be a little bit free flowing. I'll try to keep an eye on any questions that come in. You know, just to recap before we really jump into it, I have some base information that I'm starting out with, although I took some assumptions in this webinar that you are tuned in a little bit to what's been happening in the color 3D printing realm, specifically with the Stratasys J750. So, you know, whether you are a J750 owner or you've been evaluating it or you've just seen some cool marketing pictures online, you know, I do want to let you know that if there is something that you're missing in terms of how something works, definitely connect with us and we'll go into greater detail, because there really is, we could make content for this that will fill up the whole day. So hopefully it's not too much, or you know, we have an appropriate amount of time. After we cover the base information, I'm going to just talk about a little bit about how engineering CAD and software tools fit into a greater ecosystem of 3D design and 2D design tools, and then how we merge that with additive manufacturing technologies. You know, when I originally built out this presentation, I was like, all right, I'm going to come up with some really cool technical content to kind of feed anyone that's hungry about learning. And then I was like, you know what, people really need to see it, and people need to have a good use case. So I ended up designing an object, designing a product in a just about a 24-hour period from sketch to printed object in hand, and it's actually finishing up on my printer right now. So I have I screen recorded all of the design process and built that into some software demos for you to see. I did speed everything up, so I'm kind of worried about having enough time to really go into great detail, but I will upload everything for people to watch, and if they want any tutorials to follow. And then at the end, I think that we can just review, have some questions, talk about, you know, areas that are growing with hyper-realistic 3D printing and general troubleshooting. So here we go. So the basics. The J750 and the basics around material jetting or photopolymer jetting. Stratasys has PolyJet, right? That's their technology, and it works. Specifically, the J750 works by taking 6 different acrylic-based UV photopolymers and jetting it out of inkjet heads. So one example of a way that most people have their machines loaded is yellow, cyan, magenta, black, white. So those 5 materials will get you your full color gamut. And then there's a 6th slot that typically people will load a clear material in or a flexible material in. In my lab, I do the full color gamut plus our flexible material, which is called Agilus 30. And then there's one more slot, which is for your support material. So you can see I have these pictures here. It's a pretty cool looking piece of equipment. But at the end of the day, we are just depositing droplets on demand, very similarly to how a 2D inkjet printer that you might have at home works. So that is how it works. And just, you know, I think that people kind of understand what the value of the color 3D printing realm is, but just to talk about the market and the benefits and the impact that it can have within your organization, you know, I think that these 4 categories that I have listed here are good examples. I'm sure there's other markets to hit, but consumer goods, electronics, packaging, and automotive, I think are some great immediate markets. And the impact that it'll have in your organization is that it's really a tool that can empower you to do things at a higher fidelity, at a faster pace, and really drive value in relation to what it is that's going to validate a stage of product development. And overall, the impact really should be reflected onto management. However, when we look at implementing some of these workflows, it needs to be in the mind of management that if they can empower their designers and their engineers by providing the tools that will allow them to do hyper-realistic prototyping, that they will see those results. So it has to be not just a bottom-up approach, but also a top-down approach. And I think that that's really important because to talk about, because we're going to be looking at some software tools that potentially are outside of your current comfortability. So that being said, there's a couple other product updates that have rolled out in the past, I'll say half year for the J750. One of them being the addition of what they call the advanced slicer. So the advanced slicer allows you to print and control what you're jetting at a higher level than what had originally been released. This really does enable things like using both solid full color printing in combination with clear. So you can see these bottles here. They released something called the Vero Vivid. So our base rigid photopolymers is the Vero family. They released the Vero Vivids, which are going to help us expand our color gamut into much more deeper reds, deeper blues, deeper greens, deeper yellows. So that really helps us kind of expand the range of color that we can achieve. And then most recently, the addition of Pantone. A lot of people in the color branding space or anyone that does anything with design with color knows how critical it is to be able to nail down a specific color palette. So with this new update, you have the ability to print Pantone specific swatches. And you know, what would a webinar on 3D printing be without this kind of infographic here, the standard workflow for 3D printing? I'm sure that people are familiar with this, but generally how we work, we start with our CAD software. There's some sort of file exchange happening, and for Stratasys products, we use a software called GrabCAD Print. That's kind of our cloud-based platform to queue up jobs. So there's some sort of file exchange from your CAD software into GrabCAD Print, and from GrabCAD Print, you send that to your printer. And I will do a little bit of talking about file types today. So GrabCAD Print will accept a wide range of file types. Mesh, so mesh-based files like STL, OBJ, VRML, WRL, those are kind of interchangeable. Those are, triangulated mesh-based files. You have parametric formats like step IGES or Parasolid. Those are kind of parametric open file extensions, and then native file extensions. And I believe there's some more than just these, but SolidWorks and Inventor and NX and Creo, you can bring in native part files or native assembly files, and it will bring it into your workspace. So when we introduce the concept of color and texture, there is kind of this thing that happens as you're going from CAD to printing, and that is that it often requires more time spent in this file exchange area, because typically, most of our customers are designing products. They're typically engineers or design engineers in the product development realm, and they use softwares like SolidWorks or Inventor or Creo or NX, and most of the color 3D world is outside of that realm. Typically, they're mesh-based files that are built in other modeling suites. So therefore, there's a file exchange and import-export that needs to happen between these softwares. And now there's some workarounds to that, and we're going to go into detail. But it's really important that we understand that this step is what enables us to assign color and texture data. All right, so we're going to start getting into the thick of it here. I hope I don't lose anyone. I made this little chart here just to talk about how 3D tools, kind of the inception of 3D tools, if you will. So as CAD emerged in the 80s, it took fundamental mathematic principles, and different companies developed these different geometric modeling kernels. So these are kind of file types or hierarchy, a hierarchy for understanding and displaying 3D data on screen. And why I'm mentioning this is that these kernels and these file types are really kind of what creates this different realm of 3D modeling, right? So on one side, we have feature-based modeling. That's going to be like what people might call parametric modeling, or solid modeling is also a term that's associated with it. And these are like Creo, SolidWorks, NX, Inventor. There's a lot of them out there. Some of them are super high-end, some of them are low-end. And then on the other side of the spectrum is what you would call direct modeling. And there's all sorts of other words that are kind of associated with it: sub-D, mesh modeling, 3D painting, 3D sculpting. And these types of softwares are like 3ds Max or Blender or Cinema 4D, ZBrush. There's actually a lot of them out there. But it's pretty infrequent that I meet people that are like masters of both realms. And so the goal of what I really want to do is kind of show you how, if you're on this side, the feature-based side, how you can kind of get in this in-between space. And so I've carved out like maybe 5 softwares that we'll review today, and hopefully that'll shed some light on direct modeling and sub-D modeling that can help you become more color fluent. So just to kind of show people the actual difference in the modeling process. So like this whole presentation, like I said, was based around designing a designing something and fabricating it. And so I did this. I basically started this project on Monday, and I screen recorded the entire process of my modeling in SolidWorks. I'm you know, a 15-year SolidWorks user. Although I don't really practice design or product design too frequently, so yeah, this took me a little bit longer than maybe some of you solid modeling masters out there, and I fast forwarded this. I don't want to bore anyone. Actually, I'll kick the speed up here. But as you can see, you know, we're taking sketch-based features and we're extruding it, we're revolving it, we're sweeping it, you know, we're adding fillets, we're kind of doing all this stuff. This is really a example of, I think they would call this like bottom-up modeling. There's different theories around it, but this is just kind of what I know. And at the end of this project, I'm kind of making a rubber mallet. I decided to choose a hand tool. So we're making a rubber mallet today, and you know, here I am kind of making some last-minute edits, and then I'm exporting it as a mesh file for doing 3D printing related stuff. So in the direct modeling world, it's much different. I think I'm going to mute this. So this is just like a video I grabbed off the internet of you know, someone doing mesh modeling of another hand tool. So they start off by basically overlaying this object, and they start with a cube. They add a series of subdivides for that surface, and they might pull it and push it. They might manually add some more polygons or more vertices that they can then manipulate. But it's fundamentally different from feature-based modeling in that you're not defining things with sketches, and it's much more free-flowing. There are not as many rules around what you can and cannot do. And you'll notice that everything is broken down into kind of these quadrant-based areas. So that is really something that you should take with you about this method of modeling, is that it really is quadrant-based. And so people will ask, you know, can't I just export from my feature-based modeling program and import into something that will handle color better? And the answer is really no. There's no great solution for doing this exchange. There are some workarounds, you know, there is some importing, exporting, but not with the native CAD data. And that is really based on this difference of one program being polygon or mesh friendly, and one being quad friendly or quadrant based, or just, you know, these square kind of panels, where when you're modeling in SolidWorks, everything is driven by a parametric sketch, and when you want to export as a mesh, it really only knows how to output as a polygon. So if you wanted to go into something that is a you know, Blender or 3ds Max or Maya or Cinema 4D, the data that's coming in while you can import it is just different than what what tool was built for. And this is just something, this problem here has had me banging my head for quite some time, as I've been getting closer and closer into this texture color realm. But I think I have some like pretty good solutions, and transferring this knowledge to you is really based on teaching this concept of UV mapping. So UV mapping is the process that is used in these mesh modeling suites for wrapping a skin around an object. So the most basic version, you know, everyone's kind of done this thing where you make these little six squares, you cut it out, and you fold it into a cube. This is the basic concept for how color data is wrapped around a geometry. And it may not be a cube, but at the end of the day, this is how it's interpolating the object and the color data associated with it. And UV, just so that you know, UV does not stand for ultraviolet. It really is since X, Y, and Z were already taken for describing 3D coordinates in space, U and V are the coordinate system that is used to describe the coordinate system for color data and how it's mapped to vertices in 3D space. So that is what UV stands for. And there's actually a lot of different types of UV mapping, and I've divided this up to what we're going to use in 3D printing in our workflow and what we're not going to use in 3D printing in our workflow. So, you know, I'm really kind of going for like a min for max approach here. I'm going to show you a little bit about what we're not going to use, but really you want to remember that what we're doing, and you hear a lot of nomenclature when people talk about this stuff. The real terms that you should be thinking about is texture mapping, which is the 2D appearance of the object that's the image that's being wrapped around your object, and then displacement. And displacement is what people think is the texture. They feel, you know, bumps and grooves on an object. That is displacement mapping. And then there's other things called normal mapping, bump mapping, and parallax mapping. We are not going to do those in 3D printing ever. And you might hear people say bump mapping. It is not bump mapping. It's displacement mapping. So what is texture mapping? Again, we're just taking this flat image and we're finding a way to wrap it around our object. And displacement mapping is we have an image and we're using that image to actually displace the 3D geometry to create something that has a physical texture to it, right? So in contrast, the things that we're not using, bump mapping is a rendering technique that is used to fake the aesthetic of texture. So here on the left-hand panel, you can see it looks like it has texture based on this gradient map here. But if you look at the cast shadow, you can tell that the geometry is actually still a perfect sphere, versus something that is displacement mapped. You can see that the actual sphere has been changed into a textured object. Normal mapping is a technique of teaching your computer how to render light data, how to understand light data, and parallax mapping is another method that is used in rendering to tell your computer how to look at an object and fake a 3D appearance. So again, texture mapping and displacement mapping are the ones that we do with our 3D printing workflows. Okay, what does UV mapping look like? I did this very quick demo using Blender. Blender is a mesh modeling program. I started creating my geometry in SolidWorks though, because I'm not really great with the modeling tools in Blender. So I was like, you know what, I will start with something that I'm familiar with, and I'll try doing this kind of import-export workflow that I was talking about earlier that really is not it's not a great workflow, it's not a great solution, but it is a possibility. And I'm going to just kind of kick up this speed here. Let's go 1.75. You know, this is just a random geometry that I made. Just has some cool curves on it. I was trying to avoid doing anything that was just a box or a plane or whatever, because you see that a lot. All right, hold on, let's slow this down normal. All right, so here's Blender. If you've ever used it, you know that it's a little bit confusing at first. It can be disorienting to anyone that's worked in solid modeling. But as you can see, I have my mesh. It does look pretty quadrant based, but it really was kind of a coincidence here. And what I'm going to do is I'm going to unwrap this object, unwrap the mapping for the vertex planes, and I'm going to bring in my image, and now you'll see that it's on my object here, and I can export that as a VRML or an OBJ file. But one thing that you will notice, and I think think I'd bring it into another program here. One thing you will notice is that based on how that object was unwrapped, you will have some seams. And so I actually kind of show how those seams look over here. Since you're unwrapping an object, there's no way to get around this issue here. There will be a seam somewhere on your geometry. And the art of UV mapping is really figuring out the best way to create a seam or to place a seam. And this is why people that work in like Hollywood productions are really masterminds, because it's all about understanding how you're going to look at an object and what's important to you. So you've seen UV mapping. There are multiple modes of UV mapping. So what you just saw was what I would call like a custom UV map, right? We unwrapped that geometry, we laid it flat, we looked at the vertices, and we put an object on it. There are kind of what I would call 4 different methods, maybe 3. I think that I'm not the authority on UV mapping, but there's planar projection, there's primitives, there's automatic, which is kind of like an automated version of custom UV mapping. So planar mapping is when you have literally a 2D plane and you're pushing it towards an object. So if you're doing a planar map onto a sphere, you're going to have skewing on this axis here. So planar mapping, while it might work great for something that is just a planar object, really doesn't lend itself very well to things that have complex curvature. So then there's primitive mapping. So primitive mapping is really just taking this concept and applying it to primitive objects. So a sphere or a box or a cylinder will all correspond to their own primitive mapping. But when we're going to use the example as a sphere here because you can see kind of its pitfalls, each one of these pitfalls for a complex curvature object. So in box mode, obviously it's going to be good for boxy objects. Cylinder mode is going to be great for a cylindrical object. You can see here on this sphere, though, that we still have that skewing on the top. So a lot of times you can kind of pick some of these primitive mapping modes to fit onto a geometry, and it's very fast. It's a very quick way to do the UV mapping. There's custom UV mapping. So this is kind of what I had done before, where you unwrap this object and you can kind of manipulate it on a grid, and you can place your image over these different sections accordingly. This is something that you'll see a lot in character design, which is really just done in a sub-D modeling or direct modeling environment. And then automatic custom. So a lot of these tools have, a lot of these softwares have a tool where it will try to intelligently unwrap your object for you. And it's a great solution sometimes. It really depends on the geometry and it depends on what you need. But you will sometimes find these little areas where the seam gets cut up in a way that is undesirable. So, you know, if I'm doing something very quick, this might be a good method for me. But if I'm doing something that is very, very high fidelity, I might want to, you know, custom tailor my UV mapping. All right, I hope everyone is still with me here. I really hope I haven't lost you because we're going to start moving pretty fast. Let's see, we're at 1:30, so I think we got some good time to talk about these different software solutions that I've carved out. So what we're designing today, again, I designed this little mallet, and you know, my background is industrial design. I grew up in Metro Detroit. I'm a huge automobile nerd. I love classic supercars, and so I drew inspiration from the Lamborghini Miura. It's kind of like the last great supercar. of its era. And so I was like, you know what, wouldn't it be cool if I made this like hand tool that is like based off of a car? What a classic industrial design exercise. So I kind of like went back and I styled my design, and I picked out some textures, and I picked out some colors, and you know, I got a quick little video here updating my design. I was like, you know, my first design just like was not sexy enough. So I was like, all right, I'll go back and I'll add some style in there. So I'm like kind of fooling around in SolidWorks a little bit more. And as I'm doing this, I started thinking about like, how can I best optimize my design for this workflow that I'm doing. And I learned some things throughout this process that I think are key takeaways for if you are planning on implementing some of these workflows. Because like anything else in 3D printing, you really should be in this design for ... mindset. There is no easy button, but I think with some of these rules, you can just design things a little bit more smarter so that you save yourself some trouble later on. So here's the colors and textures that I'm designating. So the head of this mallet is going to be a hard plastic texture. This stem, I'm calling it. I'm like, you know what, let's do some cool carbon fiber. What car buffs don't like to see some carbon fiber. The grip, I wanted to do this like bumpy texture with the classic, they call this Mira Verde. It's Lamborghini's like trademarked color. And then there's this cap on the bottom that I wanted to do clear with like a cool logo insignia on it. So here's kind of this is the work that we're going to do. So starting off, you really want to have a good color and texture library. That's going to be the fundamental basis of executing your design well. So my starting point was looking at Mira Verde. I Googled it. It has a hex code and a Pantone code. It's registered colors. And to accurately do color on the JSON50, you're going to want to do some soft and hard proofing. So we have a workflow cut out, and it's available online. There's a handful of tutorials, and I can also post my videos as well. We basically have a swatch generator. I have this link in the upper right-hand corner. You guys can't click it, but I can send it to you. That basically, you just go in, you put in the hex code of whatever hex color that you're looking to achieve, and it'll auto-generate this swatch. And that swatch is ready to be printed on your JSON50, and it prints in about under an hour. It's about like 45 minutes, I think. And then once you have that, you can basically hard proof. And hard proofing is something that is done in the 2D printing world, right? You want to see what it looks like in front of you, and everyone's eyes see something differently. So this is a really great technique. So I looked at this and I found it was number 35. They're all numbered. So I found 35. I was like, you know what, this one looks the best. And so then I looked up 35 here, and it gave me the actual output code that you can manually put into either GrabCAD print, or if you're designing something in like Photoshop, you can use that code as well. So this was kind of my single color hard proofing that I went through. It's a very, very simple workflow. If you have a JSON50 and you're doing the Pantone update, you can just use Pantone colors. But I haven't done that on my machine yet. It came out like a month ago, so I'm a little bit behind. So if you're doing textures, if you're doing something that's more than just a single color, there's a couple other things that you're going to want to pay attention to. The starting point of this is getting good sample images. So if you're like me, you go to Google a lot, type in, carbon fiber texture, wood texture, whatever it is, and you'll grab something off the internet. But that's a flawed method, because there are things that are seamless and tileable, and then there are textures that are just literally pictures of something. And the difference is how the pattern meshes up to itself, and how any gradient lighting or gradient shadows or highlights are on the object. So, this is just me, like, poking around on Google Images, looking for something to use for this example. Now let me fast forward this. So I think I settle with this little wood swatch here, and I bring it into Photoshop. And if any of you are not using Photoshop, it's a good software to learn in the 2D space, because there's tons of tutorials online. So if you're not a master of it, it's not that hard to figure out what you're doing just by kind of searching the internet. And that's how a lot of these softwares are these days. So here I brought in my my two different textures, and you can see that if you look at how they mesh up, there's kind of this ugly line there. So that's just really undesirable when you're working in UV mapping. Whereas this other texture here, you can see is seamless when it lines up to itself. So this is something really, really important, not just for doing a small object, but also a large object, because your image size and the size of the pattern will kind of dictate how it's going to look when you wrap it around it. So if you scale it really, really small, it's going to look kind of weird, because you'll see a lot of repeating patterns. So what I'll say is, I would expect that a lot of end users, a lot of people in the product development space would want to, it's in their best interest to build up their own library of textures that work for what they do. And, a lot of companies will end up having graphic designers in-house, doing something like this, building up a catalog of textures. So that's one thing about seamless tileable textures. When you have those textures selected, there's kind of there's also a hard proofing workflow that you're going to go through. So again, similar to the color world, there's going to be some hard proofing that you have to do. You're going to print it out, you're going to look at it, and you're going to ask yourself, does this look right? So here is just kind of the theory behind what you should be doing when you go and hard proof this. First, what I'm showing you in this video is setting up Photoshop to have the ICC profile of the Stratasys J750. So the ICC profile, so ICC profiles are basically the language that your printer will speak to your computer. So your computer and your printer are communicating information, and the ICC profile is the language that they're speaking. And what's nice about Photoshop is that it has that preloaded language set up natively in the software, so that it will know what colors your J750 can and cannot print. So this is just how you set that up. Now everything that we're going to be looking at is the proofing color, and you can also see that we can mark any pixels that are out of gamut, outside of what we're capable of printing. So we want to keep that on. And once we have that set up, we're going to go into our adjustments, and we will bump up our exposure, offset, and gamma correction to the highest point that we're comfortable with. Basically, we want to limit out of gamut colors, but we really just want to bump these things up as high as we can. And the general method that we're using is that we're going to start off by overshooting our target. We're going to print something out, and we're going to back it down. So my first iteration, I'm going to print this out with overexpose, over offset, over gamma correctness. I'm going to bump up my lightness, and then I'm going to look at my hard copy that I'm comparing it to, and I'm going to say, is this accurate? If not, I'll slowly kind of back it down bit by bit. So, if this is something that you need to do, if you need to do this texture matching, let us know. I can give you a more explicit demo of doing this. And we you know, as we are evaluating the JSON50 for people's applications, we'll go through this with like your texture and show you that, you know, we can hit the color and the hue and saturation of what texture that you're trying to do. Okay, so that's my little method. I just end up importing this VRML, and I end up just like making it only 3.5 millimeters thick, so that you can just like print it out really quickly. So this is a fun little workflow. Once you go through that and you have your textures selected, you're ready to kind of go on to the next step, which is really skinning your object. So here I have, you know, we're not going to become masters at this, but just by watching the video. So I'm just going to kind of play them. The first one, I'm exporting the head of this mallet, and I'm doing this like hard plastic texture. And for this demo, I selected Materialize Magics. Now I understand a lot of 3D printing users may not have this software, but since it is kind of like a common software that you'll see, I just wanted to show you like how easy this is, although it does come with a pretty high price tag. So I just want to like get this out of the way real quick. You basically select your shell, and then you select your texture, and it'll just kind of wrap it over the geometry. So here you can see I have I can rotate. I did not find a very good tileable texture, but I was like, too late. You can scale it, rotate it, move it, and when you find something that you're happy with, you can just apply it and hit OK. So this is a great tool, but it's very limited. Like I said, like I was talking about these different methods of projecting your UV map before. This is very, very limited. So you can really only do a straight projection or a cylindrical projection. So my next demo here, I'm doing the same thing, but I'm using Photoshop. Photoshop does have some 3D tools. It was really not built well for handling 3D data, but since people are already designing textures for 3D printing, there are some tool sets that you can use to kind of do the same thing. So right now I'm looking at my UV map, and like I said, Photoshop does not really handle this data very well. You can optimize that UV map. So here you can see that it's kind of re-optimized how it's unwrapping this, but there's really no rhyme or reason to this. Although that can still work in a lot of instances. So here I'm taking this like hard plastic texture, I'm making a pattern out of it, and then I'm going back to my geometry, and I'm applying it. And when we go back to the 3D version of that, you can see it's applied. Pretty quick workflow. It might take you a while the first time that you do it, but you know, after you do it 10, 20 times, it's becomes second nature, like any other thing in your CAD workflow today. So here I'm just kind of bringing it in to Magics just to like check my work. I use Magics throughout my workflow just to kind of check my work here, and it looks pretty good. You can see there's kind of this like ugly little seam on it, but for the most part, it looks pretty nice. So that is just a basic projection style UV mapping. Now for the next component, I'm going to show you a little bit more explicit methods for UV mapping. First, I'm going to show you doing that in SolidWorks. So SolidWorks does have a tool that will let you do UV mapping. It's called SolidWorks Visualize. Again, it's a little bit limited, but I think for like a lot of geometries, you can use it pretty powerfully. So here I'm just selecting my my texture. I am fumbling around looking for the right texture here. And let's go back. All right, so I've assigned my texture. I'm kind of looking at it. I'm doing just like I think this projection that I did was like a smart UV wrapping. So this is kind of like a custom version. Oh no, that's box. Yeah, so first off, I just start off by showing the different methods and how they look. So I go through box, cylindrical, planar. This one I started off with box mapping, so it's just projecting it onto the object as if it were a box. There's a little bit of distortion on it, as you see when we go into kind of like check or verify our geometry. I'll skip ahead here, so you can see it that there is some distortion on it in areas that that I don't like. Let's see here. So yeah, there's the distortion. You can see there's kind of these like really ugly patterns that wouldn't fly for the work that we're doing today. So I go back into visualize and I play around with different methods, and I find that the cylindrical mapping works really well, and that's kind of what I had suspected. This geometry is pretty ideal for cylindrical mapping. So then I export it as a OBJ or a VRML. I bring it back into my my program that I'm using for checking this. You could use GrabCAD print as a way for checking your VRMLs if you don't have a tool like this. So you can see on the back of the object, I do have this seam. That's going to happen in most scenarios. But if you want to explicitly choose your seam, you can use a program like 3D Coat. So 3D Coat is a low-cost solution for doing explicit UV mapping. So here you can see I'm just selecting where I want my seams to be. So I'm just kind of selecting and deselecting my seams as I kind of find an ideal solution for this. I decide I'm just going to cut this object in half. I could have probably also just like wrapped it all the way around, but I'm not an expert in this software. I've spent maybe under an hour in it, maybe a little bit over an hour. So just getting rid of some of these other leftover seams. Looks good. Go into my UV planning mode. I'm just kind of like editing my mesh, and I think that I had never done this part of the workflow before, but I figured it out in a couple minutes. I ended up having to just go to a different screen, and it was already populated. Basically, I just imported and applied my carbon fiber texture, and there it is on my custom mapped UV mesh. So again, I did this one in SolidWorks Visualize. I did this one in a program called 3D Coat. You know, I'm pretty agnostic with these tools. It really just depends on what works for you. So the last demo here is, or this is one of my last demos here, is for showing you how to do displacement mapping. So like I said, for that bottom handle, I wanted to have a bumpy texture on it, something, you know, some kind of grip-like texture, maybe some like knurling or some bumps. So in this method, I'm using a program called Rhino, Rhinoceros 3D. It's a pretty popular NURBS modeling program. And what's nice about it is that it understands parametric formats. So you could bring in a SolidWorks model if you'd like, or a step or an IGES file, which is exactly what I did in this instance. It's noticing the curves on it. And my workflow here is that I'm kind of dividing it up into sections. I'm focusing on the surface areas that matter the most to me. So the top and bottom caps of this object I really don't care about. And what I'm doing is I'm going through, they basically have some custom textures in there that you can edit and change to get what you want. So I start off with just this regular bump. It's just a dot. And I change how many there are. I can change the height of it. I can change the scaling, or I can change the way that it's understanding the light to dark values. So what I end up doing is I end up kind of like diffusing it a little bit so that it's a nice like smooth bump, and then I increase the amount of dots that I have. So here I'm just kind of going back and forth between editing my texture and then editing the bump value. Now, you could also do this with your own predefined texture. That definitely requires more finesse, more expertise. So I would recommend starting with these base geometries that they have, and then learning about how it works, and then going and building your own materials. So here I'm just kind of setting up, how I want it to look. I'm viewing my render mesh, so I'm viewing the mesh that it's going to output this geometry as, and then I'm extracting it, so I'm saving it out. So, it's a fairly easy workflow once you understand how to move from one tool to another. I won't say that you can do it in 5 minutes your first time, but I probably put a couple hours into it, and now I'm pretty skilled at it. So I want to be realistic with you about the time inputs for this stuff. And I think that the fastest way to learn it is to just have a video like this in front of you the first time that you do it. And so if you do see yourself doing something like this, reach out to us and we can explicitly show you how it's done. So that is displacement mapping. So now I have basically the whole object with this texture on it, and then the last piece is mixing clear with color. So this is something that people are kind of interested in doing. So I have this clear object with this Lamborghini Bull insignia on it. So I start off by just creating a PNG image with no background. So you have to delete the white out of your object. And so I go into Photoshop and I delete the background. I save that out. I'm just kind of showing you that there's no background here. And you save that out as an interlaced PNG. It's really important to use this file type, the interlaced PNG. So as you save that out, you can then move over into a tool like Rhino. I used Rhino for this one. I brought in a step file, and basically what I do is I do a planar mapping of that geometry over my object. And once I have that overlaid onto the object, I'm kind of like fiddling around at this point in the video. I was kind of playing with it. You basically, adjust your scaling, adjust how the image is sitting on your geometry. And then the last step is you're just going to go into the material settings of Rhino and adjust the material as a transparent material. So you just go into that, and there's a transparency slider. You slide it all the way, and you just save it out. So when you go into GrabCAD print, you can kind of see that it will have a, let's see here. When you import it, it'll just look clear just like that. So that's basically the design of my object, and I'll just kind of show you, let me open GrabCAD print here, and just kind of show you the final version. I think I have a picture of it right here. I know that we're getting to the end of the hour. I do want to take questions, so if anyone has them, you can give them to me now, or we can connect offline. I can speak a little bit more about this. So at that, I will also say that I have a survey that if anyone is willing to take, it'll enter you into a raffle, and I will send you this object, this mallet that I've designed, and you can't use it, but you can have it as a reference. I mean, I did this whole workflow in about a 24-hour cycle. Like I said, I started modeling this on Monday, and my printer is literally just finishing the print job. Let's see here. Yep, just finished. So I'm about to go take it off of the build bed and clean it up. So with that, thank you very much for joining us, and I look forward to answering any questions that you might have.